Welcome to The Explainer. Today, we're bringing you an absolutely critical update straight out of the 2025 issue of Periodontology 2000. We're looking at a paper titled Engineered Surface Strategies to Manage Dental Implant-Related Infections. Now, if you're out there placing or maintaining implants, you already know the deal. Managing these infections is, quite frankly, one of the most frustrating challenges we face in the field right now. So consider this explainer your essential, high-yield update on how bioengineering is stepping up to try and solve implant failures once and for all. Okay, let's dive into this. Just take a look at this 20% statistic. The clinical reality right now is that the prevalence of peri-implantitis is pushing 20%, and honestly, it's just steadily rising as time goes on. And when these implants fail, it creates a massive burden. In fact, this rising tide of infectious complications has made the cost of maintaining dental implants literally 5 times higher than maintaining natural teeth. 5 times! That is just a staggering economic and clinical reality. We desperately need better solutions, for sure. So, what exactly did the researchers look at to address this mess? Well, in plain English, they pulled together a massive, systematic scoping review of decades, literally decades, of preclinical and clinical data. They wanted to see which of these fancy implant coatings actually do the job of stopping the complex polymicrobial biofilms that end up ruining implants. And they didn't just check if a coating kills bacteria in a petri dish, right? Because that's easy. They evaluated in vivo animal models. They assessed real human clinical trials. And they really zeroed in on how these surfaces modulate both the biofilm itself and the host inflammatory response. The researchers essentially broke down the existing tech into 3 core mechanisms. Number 1, you've got anti-biofouling coatings. These are designed to physically or chemically block bacteria from attaching to the titanium in the first place, kind of like a microscopic nonstick pan. Number 2, there are contact-killing and drug delivery surfaces. These rely on things like localized antibiotics or antimicrobial peptides to just blast the bacteria right at the surface. And number 3, we have active coatings, which are these smart, stimulus-responsive technologies. Now, biomaterial science has advanced at lightning speed, but the paper points out something absolutely crucial. No single coating has completely solved the problem yet. Now, what's really interesting about this slide is the massive, incredibly frustrating gap in clinical translation. You can see the disconnect right here. The researchers tracked down 140 successful animal studies testing these advanced coatings, but when we pivot to human clinical trials, a mere 20 actually made it. 20! We are incredibly good at curing these infections in mice and rats, but bringing that success into the complex, dynamic, oral environment of an actual human patient, that is proving to be a monumental hurdle. Let's anchor this with some actual clinical data directly from the study, detailing those very few technologies that actually got tested in humans. Take the Straumann SL Active Surface, which uses a chemical modification. At a 1-year follow-up, it did show lower counts of the red complex, particularly P. gingivalis. Then you look at Neodent Aqua, which utilizes a surface-free energy modification. At 1 year, they saw no significant differences in clinical attachment or probing depth. And then you have experimental glassy coatings like NanoCare, which right now are pretty much only popping up in case reports. The big takeaway from this data, it's just how few of these technologies ever reach robust human trials. And even when they finally do, the follow-ups are incredibly short. Usually we're talking about just a single year. So why is there such a massive disconnect here? Honestly, it boils down to lab success versus clinical reality. In the lab, these coatings are tested against single bacterial strains over maybe a few short days. Under those perfect, controlled conditions, they look highly effective. But clinical reality is a whole different ballgame. Peri-implantitis is not caused by a single rogue bug. It is a highly complex, chronic, polymicrobial biofilm condition, and it usually develops 5 to 10 years post-placement. A coating that releases a quick burst of antibiotics in the first 2 weeks, it simply isn't going to protect an implant from a massive biofilm shift 7 years down the road. So, the crucial point is perfectly captured in this quote straight from the researchers. They wrote, "Bioengineering progress has outpaced our understanding of implant infection pathogenesis. Simple biofilm control is insufficient." You see, we've been so hyper-focused on engineering these surfaces to just kill bacteria that we completely missed the bigger picture. Killing bacteria just isn't enough anymore. To truly succeed, we have to modulate the host's inflammatory response and actively manage the resilience of the entire microbiome. Okay, so what does all this mean for you, the clinician grinding it out in daily practice? It means that until these next generation surfaces are fully perfected and actually hit the market, your primary clinical takeaway has to be a renewed focus on predictability and preventative dental care. Success means we have to shift away from just reactionary cleaning when an implant is already failing. Instead, we've got to focus on long-term predictability and true preventative practice management. That means maintaining strict hygiene protocols and actively managing that host environment way before the disease cascade even begins. But hey, the future is incredibly bright. The authors point specifically to active coatings and devices as the next real frontier. We're talking about smart, self-regulating strategies that actually respond to stimuli to actively modulate the biofilm back toward a health-associated profile. Specifically, the study highlights the absolute game-changing potential of PEMF. That stands for pulsed electromagnetic fields. PEMF acts as a healing device strategy that can actively modulate those stubborn polymicrobial biofilms directly in situ. It shifts them right back to a healthy state, and it does it without damaging the delicate implant surface. If you want to stay ahead of the curve on groundbreaking technologies like PEMF, you need to follow Magdent on Instagram and LinkedIn at Magdent MED. You can also just scan the QR code right here or visit magdentmed.com to book a demo today. As we make this massive shift from reactionary cleaning to proactive biofilm modulation, the real question is, are you ready to bring the future of implant survival into your practice today? Thanks so much for joining me on The Explainer, and as always, keep innovating.